Hey guys, hey, good morning and welcome. This is Dr. Veku again, and today, um, as we said, always we'll be talking about artificial intelligence, advanced artificial intelligence, and of course, it is our weekly course. This course is meant to introduce you to advanced artificial intelligence concept. It is meant to help anyone joining to be able to understand what artificial intelligence is all about when we're talking about it in the technical terms. This course is not going to be talking about ChatGPT, how to prompt all the new AI tools that are built. It will, however, be talking about concepts that are used to build those tools. So the technical details as far as those tools are concerned. How was ChatGPT built? How is Gemini built? What's the core components of those tools? What's making up that tool and all that? Those indeed are the things that we'll be talking about in our session. So please join us, share our video so that others can join. So let's see. We have 4 persons joining us. Thank you for joining, guys. Don't forget to send us your comments and let us know what you think. We're going to make it lively, answer all your questions. We're going to try to, be as responsive as possible. So please share our videos so that we can continue working on this course. So the course, as I said, is going to be 8 weeks, but technically it will not be 8 weeks. It's designed to be 8 weeks for master students, but here we're going to take it slow, and each week of content could take more than 2 or 3 weeks for us here on the platform, right? But the course is designed for master students, and so they take the course for 8 weeks. It involves a lot of hands-on work for them, assignments and all that. But here we'll not be doing assignments, but you can follow along and do the assignments. And so today we'll be talking about the second week and decision making. We're talking about decision making in AI, and it's a big thing in AI, right? Because as you can see, it's AI is all about making decisions. You introduce a problem for AI to solve, and how will it solve that problem? You solve the problem by going through a series of things, and it makes a decision. It makes a decision at the end, right? And the output of that decision is what you are expecting to use is your goal, right? So that's it. And that's what we'll be talking about today. So let's see who is joining. Let's see. We have 5 people. Please share so that we can start with at least 10 viewers. So we have 5 already. And let us have your comments. This is broadcasting on YouTube. It's broadcasting on LinkedIn as well as Facebook. So please let us know if you have any comments, or if you have anything that you want us to discuss outside AI, IT in general. I'm able to help as well. And at the end of this 8-week series, what we're going to do is we'll be practical a bit. We're going to take AI use cases, and help demonstrate how you can build an AI app, right? An AI app, and how you can make that app available to users, and how users can prompt using that app, and just a practical use case of how models are developed and how those models are leveraged. All right. Can you give a recap of last week's session? All right, Mr. Valentine, I will try to give a recap. So you're connecting from YouTube. Awesome. So last week we introduced AI in general, and we said AI was basically, it was basically an imitation of the human reasoning processes and the human intelligence in general, right? That's what we said AI was. Basically an imitation of that intelligence, that human intelligence by AI systems or by AI agents, what we call AI agents, or by AI, right, or computer systems. That's basically what AI is. And then we went into, into details about what some of those processes are, the core components of those processes, and what really makes that AI, right? And we said AI is able to learn, and the human being is able to learn. You are born blank, right, and you learn over time. And it's the same thing with AI, and that AI also is able to reason things logically, right, and solve complex issues just as the human being would do, right? So AI is basically imitating or mimicking that human reasoning capacity. And then AI is also able to perceive, it's also able to make decisions and communicate those decisions to its audience. And we looked at key components of AI, and we saw that some of the key components included data, and we said data was a huge factor as far as AI is concerned, and the proliferation of AI today is as a result of growth in data, data's variety, the variety of data that we have. We looked into the concept of big data and how big data has affected the growth of AI, right? Because training models really need a lot of information, a lot of data, and so to be able to get accurate models, it needs to be trained. These models need to be trained, and so lots and lots of data are needed. As a result of the volume of data, the velocity of data that we get from, and the variety of data that we get. Imagine the number of tweets, the number of Facebook posts, the number of YouTube videos, and data that comes in different varieties. When we're talking of varieties, we're talking of audio, visual, text, different formats of data that is coming in every day. And we said data that is coming in 1 hour today is more than data that was coming in a whole century, some years back, right? And also the advent of cloud computing and computing in general, computing power has exacerbated the prevalence of AI in our age, right? And so we said AI, AWS, Google, and all these cloud platforms have really enhanced it by the fact that they're providing computing power to process the humongous amounts of data that are coming in, and the computing power to be able to even store this data, and or the storage to be able to even hold this data, and also the development of algorithms and expertise in the area, in the AI area, have all contributed as key components of AI systems. Then we looked at the different types of AI, right? And we looked at the history of it and the different types of AI. We said there's narrow AI and strong AI, and that this strong AI is going to be, and then super AI as well, where we are thinking that AI will supersede human intelligence and be able to take actions and train itself and and perform actions that may even be better than those that the human being could perform. And there are ethical debates as to whether this is a good or a bad thing, right? And we discussed a little bit about that. So that's what we did last week, and then we saw the application of AI in different industries, and we looked at a specific type of intelligent agent, and gave a demo of that type of agent. So you can see all that information in here in week 1. So if you go to week 1 and scroll, go here, you can do the demo yourself and see the different types of agents that we did. And when you did a simulation, you saw what the intelligent agents were doing. We looked at the different types of intelligent agents. We selected the Q-learning agent, the SARSA agent, and the random agents to get different results and different accuracy levels based off of the types of agents that we chose. So that's what we looked at last week. Sorry for those who were here for this repetition, but yeah, I think it was important. Yeah, so Valentine, that's what we did last week, and today we want to look at decision making, right? And thanks, Sembe, thanks, Big Sophos, thank you very much. And today we want to look at decision making in AI, and it simply refers to how AI systems select the best actions from a lot of from a lot of other possible actions that it could take, right? So making a decision whether to move right or left is a structural. AI doesn't just move right or left. It's not just random. So AI has to make decisions, or AI agents have to make decisions. And how do they come about those decisions, right? Are some of the things that we'll be looking at under decision making. And AI decision models aim to mimic or support human decision processes. Remember, we are focusing again on AI mimicking or supporting human decision processes, right? And these processes involve what? They involve perception, they involve reasoning, and they involve action, taking action, right? That's basically, how AI mimics or tries to follow what human beings do. And they do this in different categories. You will see that they do this using machine learning based decision making. They do this using optimization-based decision making and different types of decision making, such as probabilistic decision making. You have different types of decision making. So today we will be focused on that decision making. So we're having trouble streaming to Facebook. This may be an issue on Facebook's end. All right, so we'll keep going. I think there's an issue on Facebook, but other platforms are able to stream this. All right, so let's go ahead, right? So when we're talking about decision making in AI, we're saying that decision making is just a process that AI goes through in order to arrive at its goal, right? To arrive at a conclusive, at the solution, to arrive at the goal, and that goal is a solution, right? And search algorithms, you see, we're just starting with search algorithms, are ways through which, or strategies through which AI is able to find solutions when they are doing the search, right? And so such algorithms are fundamental concepts in AI that enable the agents, so AI agents, intelligent agents, of course, to be able to find those solutions. And they find the solutions by exploring different spaces within the range of possibilities that are presented in front of it. So you have say we have a grid. That grid has multiple things, right? It's little circles or little call it rectangles or squares or whatever, right? And you have 4 possibilities. You're in the middle, you have 4 possibilities. How do you make the decision whether to go right, up, left, or down, right? AI systems, therefore, will be able to figure out how to go towards the goal. If the goal is the far end of the right, it will figure out how to get to that goal, which is far end of the right, through a series of possibilities, right? That's basically what we're saying. And these algorithms are used to navigate from an initial state. So these search algorithms are used to move. And remember last week we talked about the various states. We talked about the initial state and so on, so on, the final state and so on and so forth. So sorry, I have a cold and some cough. So permit me to cough sometimes. And we're saying these algorithms are used to navigate from an initial state to a goal state. And they do this in order to arrive at a particular goal, right? And there are different types of algorithms that can do this, that can get you from an initial state into a goal state to make a decision, right? You have to move from somewhere to that decision, from a complex place to that decision. And so there are different algorithms. Remember last week again, we talked about algorithms being one of the key components, the development of algorithms being the key components that have pushed AI systems to where they are today. And we're saying that anything that AI does is through an algorithm. And for decision making to be decision making, AI uses a series of algorithms to be able to reach those goals. And there are some algorithms that are called uniformed search algorithms that AI systems use. For instance, ChatGPT. How do you think that ChatGPT will get from point A in its search? So let's say you ask ChatGPT, hey, can you write me an article about this? How do you think that ChatGPT moves from understanding your question, researching your question, and focusing on your particular need and bringing out that output to you? And so it uses things like uniform search algorithms. And the first type of algorithm in this space is called breadth first search, what is abbreviated BFS. So let me see if there are any comments. Let's see. I see Facebook is still having some issues. Don't know if you can see us. Good work, Doctor. Thank you very much. Virgo, connecting from YouTube. Thanks, Mr. Valentine. Monsieur Ivo, thank you very much. Thank you for joining. All right, so let's go ahead. Please, if you have any questions, just drop them on. We will tackle them, whether it's in AI or something else. I think we should be able to touch on your questions, guys. All right, so let's go ahead. And we're saying that there are different types of these uniform search algorithms, right? And breadth first search is an important one, right? And this type of algorithm explores all nodes at the present depth before moving on to nodes at the next depth level. That is a huge definition of it. And it uses a structure called first in, first out, which is also FIFO, abbreviated FIFO. And so let me get a picture or an image of what this breadth first search looks like before we can discuss it. All right, so let me just go on Google here. Give me a moment. I'll share this and images. I'm trying to get the right image here. All right, so let me see. So let me share this so you could see. All right, if you can see my screen here, all right, give me a moment. All right, so if you can see my screen here, right, we have two types of things here. There's breadth first search and there is depth first search. So the first type, which is we abbreviated BFS, is breadth first search. And you see that this covers the entire breadth. So let's assume that this is your goal, that number 4 or number 7 are your goal, right? Let's assume that number 7 is your goal. What happens with breadth first search is that if this is your initial state, you will have to move from your initial state here and go to 2, right? And if you don't find your goal here, you come back and go to 3. If you don't find your goal here, you come back and probably take this again and go right here. So it searches the entire breadth, it searches all the nodes. So this will be called nodes, right? The initial places where it finds itself. It will search every possibility within the space, within the environment that it finds itself. We'll make a search through all of this. Imagine it, we'll show a demo of this in real time, right? And then once it's exhausted everything, it will then move to the next depth. And the next depth is it will probably go here and go search at 4. And if it doesn't find the goal at 4, it will come back here within this same node and explore everything within the same node, right? It explores this. So the depth, it's covered all the depth in this layer here, and it doesn't find anything. It goes back and comes back to this node, goes again, searches everything here. It has no other possibility to go here, and then it comes back, searches everything here. So it's gone all across the breadth to be able to find its goal, and its goal is number 7. So you see, they are saying here that traverse through one level of children nodes, then traverse through the next level of grandchildren nodes, and so on and so forth. While the depth first search means that the agent, the AI agent or the AI system moves from its initial state, which is this state here, and goes, if this is the goal, it will move from here. So if based on the parameters that you're giving it, we'll look at what parameters are. They are the environmental factors, they are the influencing factors that have been given that AI. Based on what it knows, it will make a decision whether to move this way or this way. So if it moves this way, depth first search means it will search all through, and maybe its first search could lead it to arrive at that conclusive goal already, right? But it will search all through. If it doesn't find its goal, it will go again and search all through, right, to the last node under here. So you come down, go back, come down, explore everything right down here, and then come down, go right down again and explore everything. It doesn't end at the initial state. If it doesn't find, it goes back and then continues. No, depth first search is it goes all across and it goes right to the depth of it. So you see, it says traverse through left subtrees first, then traverse through the right subtree. So it will go all through and then go all through to get to its conclusive, to arrive at a goal. So it's making decisions as it is progressing. So the AI system is making decisions as it, it navigates to its solution. So that's basically what we mean by breadth first search and depth first search. So let's go back here to our definition. So breadth first search would therefore explore all the nodes at the present depth. So you see, we explored all the nodes at the present depth before moving on to nodes at the next depth level, right? And it uses a system called first in, first out. First in, first out is a queue system where it takes the first inputs and then it explores all the possibilities in that first input. So say you have a messaging system, right? It's a famous example with things like Kafka and all that. And so say you have messages that are coming into your phone, and you have workers, like a number of workers who sit there serving people who are coming. Right, let's use that example. Say you are a toll gate, or you are at the airport, and you have people lined up there. Everybody is standing on the line, and you have 4 lines, and you have 4 people here serving. The first person who comes in has to be served first before the next person who comes serves, and they go. The next person comes, serves, and it goes, right? So first in, first out. So you who came in first, You have to be served first before the next one is the same thing. This thing explores the depth of the first layer of nodes, explores it first and clears it. If it doesn't find its goal, it then moves to the next level of the nodes, and it goes across and searches all that layer before it reaches its goal. That is a process through which AI agents make decisions. So let's see if there are any questions as far as this is concerned. Oh, it's Father Clement. All right. Father Patrick, thank you for joining. Appreciate it. All right. So that's the first layer of search that occurs, right? Which is called it's called the breadth first search. And then we also just explore the second type of search, or the second type of algorithm that AI systems use to arrive at the conclusion. And this was the depth first search, right? So the depth first search is just as we explored it. It goes all through the possibilities in all the nodes in its track, and then it backtracks, right? So explores as far as possible along each branch before backtracking. And it uses a stack data structure for frontier management. So it knows where it started, right? It uses a stack data structure. It knows where it started, the initial state, to be able to backtrack and go to that initial state before coming back to continue to the next level. And DFS is not complete in infinite spaces and not optimal, but has a linear space complexity. This just explains that structure that it takes. So that indeed is another search type or another algorithm type that AI uses to make decisions. You have others that we'll be looking at here. You have a uniform cost search. These are all dependent on the above ones. This one simply expands nodes in order of increasing path cost. So it depends on the cost factor that is involved within the nodes. So say you use a number of credit. You use 1,000 credit to explore all these nodes. It will it will gauge what number of credits you will use to arrive to be able to complete the first node, and it makes a decision whether to go on or not. So this is based on this, but it just includes the cost factor. And there's a way that it calculates it using the cumulative path cost. We'll be seeing this as we go along. We'll explore all these algorithms as we go on, right? And then there's the iterative deepening search. And this combines the benefits of BFS and DFS by performing DFS to a limited depth. So this is just this, and it uses a little bit of this and a little bit of this, and it's called iterative deepening search. So you see, all of these are all based on these two factors, or on these two algorithms. It's just a combination of both that makes the iterative deepening search. And then you have other search types, including the informed search algorithms. The informed search algorithms are interesting because these are based off of data that you give it, of information that you give it. The very first type is called the greedy best first search. The greedy best first search. And this algorithm type expands the nodes that appear closest to the goal according to a heuristic function. We will be learning what a heuristic function is in a moment. We will start going into that, immaterial also a little bit. So this uses some input, right, that is given it to locate where the goal is. It uses some factors to locate where the goal is, and that's why its search will be going directly towards the goal, because it has influence. It's been influenced by an outside factor called a heuristic function. And it uses a priority queue order, a priority queue. So it uses a priority queue, so it can skip other nodes based off of the heuristic function. So it prioritizes some nodes. And remember, some nodes, when I was showing you that diagram, I was showing you that the node is that particular state where it finds itself. So it uses a priority queue ordered by heuristic value. So the values that are given it by this heuristic function is what it uses. And then we have another that is A star, the A star search algorithm. And this one combines the cost so far, like in this search here on this one, so it combines the cost with an admissible heuristic estimate of the remaining cost. So it combines this one and this one to be able to get to a goal. So this one uses a complex system that is a combination of two others above here. And then there are others that we'll be learning, there are a lot of them, genetic algorithms and so on and so forth. And there are key concepts in search algorithms. Don't want us to go into the details here, but there are key concepts that we need to know when we're dealing with search algorithms. The first one is the state space. And the state space is the set of all possible configurations or states in a problem. So all environmental factors, everything within that space is called the state space. And then there's the initial state, which we defined last week. And this is the starting point of the search. And what is performing the search? The AI agent or the algorithm. And then the goal state is the desired end or the state or solution where the agent wants to be. It's like the decision point. And then the actions are the possible moves or transitions between states, the possible things that the agent can do. And then we have the path cost, which is the cumulative cost of taking a sequence of actions. So what is the cost for you going from using depth first search, right? Going right to the bottom, coming back, going back. What is the cost that it takes that AI agent to move, right? And then the search strategy. It is indeed the approach that is used to explore the various state spaces. And we define the state spaces here. So those are some components that make up a search algorithm. I want us, therefore, to explore what this could look like in action, like in the grid example. We saw this grid example last week, right? So today, we will be selecting an algorithm type, and then it will use a grid and explore possibilities. Let's assume that this grid right here, right? This green is the goal. That is actually the goal, right? And this is the initial state. Remember those key factors that we just saw. So the initial state, we saw the nodes. These are all the nodes. And then the goal, you see, this is the goal, this is an empty space, this is a path it will take, and these are obstacles, Assume it's your house. It's an algorithm that is built on top of the agent that cleans your house, right? How will this thing be able to reach this goal with these obstacles in front of it, right? So it wants to trace a path for itself to reach this goal with all these obstacles. You could do this. Last week we saw the cleaning of the house and so on and so forth with the previous algorithm. This, we would just want to trace a path that reaches here using the minimum cost, because you want to always consider cost. In AI, you consider cost a lot, right? And that is how you determine whether your model is accurate. Model accuracy is very important. So if I build a model that behaves like that's as slow as a human being, then of what use is that model, right? You don't want to do that. You want to build a model that achieves a goal in a very short period of time using a little cost, right? And so in this case, we are choosing breadth first search. Remember what breadth first search is. We defined it just a moment ago. Remember what breadth first search is. We just defined it. And we're saying that breadth first search will explore all the possibilities within its breadth, right? So we'll explore everything near it, right? Within the initial node, within the nodes around it. So we explore all those things before it will go down to the next layer of nodes and right there. So with this, you already see that this may be longer than any other type of algorithm. So if we hit start, right, you can increase the speed here or reduce it, just depends on you. So want to reach this goal, right? And you see, it's checking everything within its breadth, within its layers. And then you see, it's going down every possibility. So you probably go this and explore all of these things before it eventually goes to reach its goal. Look at the possibilities it's taking. So it has to explore everything within its first layer, explore everything before it goes and it finds the goal. And then it traces a path to take, right? You see, it explores everything before it goes and finds the goal. You see? So it's found a goal and then it's given you a direction to take. You see, it's traced a path that it should have taken. So if it went like this directly, it should have reached the goal in no time. So with this, therefore, it is able to give feedback. It is able to give feedback to the model, and the model will learn from it and say, oh, yeah, next time when I'm faced with this type of problem, I'm able to use this path and get to the goal, right? And so you see that the algorithm explores all neighbor nodes at the present depth before moving to nodes at the next depth. And so it took 52 cells. Let's see, yeah. So it visited 52 cells to be able to even reach at the goal. But the path length, you see, the path length is this actual path length right here. It could have taken just 15 cells to be able to reach at the goal. But what did it do? It explored everything to be able to reach the goal using 52 cells. So the cost here is 52, right? So if this 52 were to be measured maybe in credits or in dollars, you see that it's a lot of dollars as compared to if this model were tuned to be able to figure out that it can get to this goal just through this path right here. And so the team that is using this algorithm will be fine-tuning it with training data sets, with different use cases, with information, so that this model, when given this same scenario, should be able to go through this path using just 15 credits. So that's what depth first search, the breadth first search does, right? All right, let's look at the next one. So you can clear this or reset this grid and go to the next one, which is DFS. So this is how it will function with all others. And again, this is the goal. This is the initial state, and this is the goal right here. All right. So if I come in here and click on the goal and click on start, sorry, you see how this one will go. It will go all the depth till it hits an obstacle. It goes all till it hits an obstacle. It comes back, goes down. You see how it keeps going. It goes down till it can go no more, hits and goes explore. You see that there's nothing, it backtracks and it goes up again. And all that it hits a block, goes and it reaches a goal. So this one explored, it reached a goal faster and it explored just a few, not a lot of cells to be able to reach its path. But the path length is longer with this model. The path length is 21, but it explored only 28 cells to be able to reach its goal. And so you see the benefits of each algorithm, and teams would choose algorithms based on the factors that are influencing the algorithm, right? Based on different factors. There will be a lot of factors that are influencing the searches that teams, or the algorithm types that teams decide to use. There are different types, the A search and so on. So you can explore this yourself by going here and going to, search algorithms, and you can explore it. There is also, give me a moment. Okay. Hey, I'm having some stars from Niger, from V. Thank you very much. Thank you. Appreciate it. All right. So let's go to the next thing. So it's 10:41. We have about 20 more minutes. So let's visit the next thing else, our classes will be too long. Our sessions or our weekly sessions will be too long. So the next thing would be adversarial search. Oh, so I'm forgetting, there's a code implementation for this that you can explore, right? There's a code implementation for all of this, as I showed last week. You can explore it. And I can also just run this and show you how it looks if I were to run it in my VS Code environment, right? And I'll share that environment with you. Give me a moment here. Let me see if I can bring it up. So I will start Jupyter Notebook, right? I'll start Jupyter Notebook on my system, and then I will bring it up. So let me bring Jupyter Notebook up. All right, sharing the Jupyter Notebook, and I will choose my Jupyter Notebook. This is my Jupyter Notebook environment, and I'll paste the code snippet. So the code snippet is something like this. Like it's a basic, it's the same basic search algorithm that we're looking at, right? And so what I'm doing here, I'm importing some libraries. We call these libraries, right? And so these are just functions or helper code that has been built by different open source teams, and put out there so that you can use it to do anything. So we have the heap queue, we have time, OS, sorry, and others, right? And so we're importing them, which simply means we want to pull it down and use it. And I'm using a Jupyter Notebook environment. I said you could do it online. If you search for Jupyter Notebook, it will give you Jupyter Notebooks, right? It's a project, an open source project. You could open this up and you can use an online an online free version of it, or you can install it in your system and use it. It's a Python environment. You see, you can try it on your browser. So if you try this, you open up like this and you can put your code on it, right? Select the one you want to use. So for example, this one, it will bring up something like this. And then you can open up cells and use and build your code on top of it, right? So if you do this, open it up, you can put your code right here and you execute. It will give you the same type of results that I wanted to do up there. So let me explain the code. So this one is on my local system, right? So this one is on my local, and I've opened it up. So the code just, these are just colors that I'm setting. I'm setting some color types because I want to use the colors. And then I'm assigning particular colors to different dimensions here. And I'm writing simple functions. A clear screen function. You know how you type CLS on a Linux system to clear your screen, or you type clear on your terminals, on your CLS on your Windows terminal to clear your screen, and clear on your Linux-based or Unix-based system to clear your screen, right? This one is CLS. So it just clears your screen, and this represents a node in a search tree, right? The node can either be in one state or another, and you have the initial state, you have the parent state, you have different types of state, and you have a path course. Remember, we're talking about the path course. This is how you can define that, right? And many other things that I'm defining within the code. I will not be explaining this code in detail, but it just does what you are seeing in the grid. So if I execute this, right? If I execute this, you could decide to see the result with the animate true. You're animating it with the colors and everything, or you put it to false. It will give you the expected result. And so if you use this, you see I'm moving from an initial state, right? So I'm moving from an initial state just as you saw in the grid, and I'm moving from the initial state to a goal state. So this is the initial state and this is the goal state, right? So using different types of algorithms, I'll be moving to the solution. So for example, solving a puzzle with A star. So A star will be using the A star heuristics. Remember the heuristics that we defined to move, to take actions like down, right, up, left, and so until it reaches its goal and it tells you the goal. It's just that the code will run so fast and you'll not be able to see the actions it's taking. But then it will show you the actions represented by this coloring down here. Let me show you each step it takes right up to the bottom. So it just does the same thing like the one I was sharing with you a moment ago. But you can explore that. Let me see if there are any questions here. No, no questions. All right, let me share back my screen um, on the course itself. All right, so this right here is the code snippet. You can play around with it and exploit if you want. But the next thing that we want to do is adversarial search. Adversarial search, very important concept as well as far as decision making is concerned. And so adversarial search is all about a class of algorithms that help in decision making in competitive environments. So this one is not just decision making, but it's decision making in competitive environments. And that's why it's termed adversarial. You have adversaries, right? So you're placed with competition, with things that all influence your possibility of reaching a goal. You're faced with that and you need to make a decision. So adversarial search is therefore a group of algorithms or a group of algos that help in making a decision when you are influenced by certain environmental factors or competitive environmental factors. And so multiple agents in this case would have conflicting goals. And these algorithms are used especially when you are playing chess or games, right? Playing games, you know, different things in AI where they help determine the moves that you take, right? So assume that you have a chess game to play, you have a game to play. The adversary has knowledge that you don't have, and you have knowledge that the adversary doesn't have. How do you arrive at the goal in that scenario? There are key characteristics that are involved in this type of algorithms. There's the fact that there are multiple agents, which involves two or more agents with opposing goals. There's the turn-based. Agents typically take turns making moves. So you are playing draft or chess. This person has to play first. So there are rules that are set, right? This person has to play, then you play, he plays, you play. So there's turn-based. And then there is a zero sum. Often, but not always, one agent's gains is another's loss, right? So if you gain, I lose. If I lose, you gain. There is that zero sum possibility. And then there's the perfect information. Classic algorithms assume all agents know the full game state. All of you have, you understand the state. Say you're playing cards, right? All of you understand the rules of the game, you understand everything, but you don't know what the other person knows in terms of their cards, the cards that they own, right? And then tree search. All of them explore possible future states by building a game tree. So it goes through a process throughout the tree. And then key algorithms in this type of, in this type of search algorithms include Minimax, alpha beta pruning, Monte Carlo, Monte Carlo tree search, and there's the expecti minimax algorithms. So the first one is recursively evaluates positions by assuming both players make optimal moves. So this algorithm is tricky. It figures out, so it's thinking like the human being. It figures out that Mr. B, who is my opponent, is making his best moves to arrive at this goal that all of us are searching for. And you, the other agent, you're assuming that Mr. A is using its optimal options to arrive at that goal. And so the algorithm alternates between maximizing and minimizing levels in the game tree. And it's an interesting algorithm. The second one is the alpha beta pruning. An optimization of Minimax So it's just optimizing. When we talk of optimization, it's just it simply means improving. It's an improvement of the other one. So it's an optimization of the minimax that eliminates branches that cannot influence the final decision. Any branch that cannot influence, or anything, any influential factor or any environmental factor that has no influence on the final decision, can be kicked out. Um, and it maintains two values, alpha and beta, to track the minimum score. The maximizing player is assured, and the maximum score, the minimizing player is assured, best case text complexity and all that. So it uses this formula to arrive at its goal. And then the Monte Carlo, I'll be showing you in a bit, uses a random sampling to build a search tree and evaluates moves. So it uses random sampling. Random ones sometimes turn to be very costly. And it goes through four phases: the selection phase, the expansion phase, the simulation, and back propagation phases. And this one explores different factors, different possibilities, but it randomly samples them, right? So it just picks and chooses, and it picks and chooses, and then it tries to maximize on those that is chosen. And then you have the expecti minimax. I don't know how to pronounce this one. And this is an extension again of the first one, for games with chance elements. So it has that chance element depending on, for example, you roll your dice, your dice falls, it can either go this way or that way. So it includes chance nodes that calculates expected utility based on on various probabilities. So it takes into consideration probable factors and uses chance to be able to arrive at its goal. So you have some historical factors about it. You can read them. Then the demo, you see, you have things like the tic-tac-toe game and so on and so forth. So you can choose an algorithm to use, right? The minimax, alpha, beta, this, or the other one, and then you can use it to play the game. So you can choose AI versus AI mode. So AI versus AI mode to play this game, right? So you turn this on, you see a player, you see a current player. So let's try that and see. AI is thinking. So this is, let's see what it does. So it's going around and playing. You have two players. There's one that is using the O's, one that is using the X's. And at the end, one wins. And you see that X is able to reach 5 points, 1, 2, 3, 4, 5. And so it's probably the winner of this simple game. And so here you'll see what it did. Let's see the points that it took. It moved through various steps to reach its goal. Game ended in a draw. So this one is saying that the game ended in a draw, but one person had 5 options. Five. And let's see. Let's try this. Okay, let's do a new game and try without this mode. Let's see. Oh, it automatically turns it on. Let's see. So it starts with an X again. It's the same minimax that we're using in this one. Let's see what wins in this game. So this one plays, this one plays, this one plays, this one plays again, this one plays, and it ended in a draw. Now let's try to clear a new game and use alpha beta, right? So it's using alpha beta. Let's see what happens. Current player is thinking, it plays, it's like a chess that it's all playing. Game ended in a draw. So all both systems, since it's all AI, everybody knows what every other person knows. It does the same thing. So let's do a new game and use Alpha Monte Carlo. It's thinking. It's thinking. player X wins. So X wins in this case, right? So player X wins in this game. Let's see. So this algorithm is probably better for playing this type of game. Let's see. Try a new game using expect T minimax. So it's moving from point this to this. So these are just points. When represented in code, it will just be values like this. And current player is thinking, game ends in a draw. So this will probably be the best search algorithm to use in a scenario like this one. All right, so you can see the minimax. This is just a minimax demo, and you can see comparisons how each of the models will perform, right? So you see comparisons the way each of those models will perform in scenarios like the ones we did. And then the code implementation again is just this, and we're defining each function. So this is the minimax search, and you're defining it here, and then you give its values based on the states that you have and all that. Let's see. Yeah, so this is just a snippet of the minimax one. All right. So this is 58. I think we'll be ending here today, making simple decisions. Next week, we'll start from here, making simple decisions, and then we'll go through the entire process. So today we just wanted to look at decision making, how AI systems are able to make simple decisions, how they arrive at a goal, right? And so they use certain algorithms to be able to arrive at a decision. Let's see if there are any questions here. Yeah, no questions. So they use different types of algorithms to be able to arrive at a goal. And to arrive at a goal, you could have different scenarios. You could be faced with a lot of possibilities. You could be faced with adversaries. You could be faced with different situations, and you have to make a decision in those situations. There are influencing factors that could make you to choose what path to take. And so that is the same thing. For example, ChatGPT, when you're giving it information, it has to have knowledge of the way you prompt it, the information you give it helps direct it on where to go, right? And we'll be seeing how things like ChatGPT and the rest are developed over time, and how those LLM models, you hear a lot of people talk about LLM models, how those models really are able to do what they are able to do, right, over time. All right, thank you guys. So we're ending it here. It's almost an hour, and these sessions are just 1 hour. Thank you so much for those who joined and shared our video and commented. I really appreciate it. Next week we'll continue with week 2. So it will be week 3, but we'll continue with week 2 since we couldn't explore all of it. It's going to be a lot of content, so we're going to go fast. But yeah, let me know if you have any questions about anything, how to get into IT, how to get started. If you're already in IT, how to build on your career, how to develop, within the AI space, or you're looking to improve on other areas. We're always here to help guide you. All right, thank you very much, and that's it for today. Bye bye.